circle or something. But let's look at a vector expression. How about, this is on page 852. This is in section 13.2. Here's the vector curve they give you. RT, T sine of T, T squared, and T cosine of 2T. What do they want you to do with this? Say, can you find the derivative? Well, I can write that as R prime of T, right? Hey, another name for this vector function, isn't this the tangent function?
Mm-hmm.
So I'm going to write that. Just so I'm in position function, this would be the tangent function with the tangent vector, right? At different variables of t. So if we think of this as position, I can also think of this as velocity, true? But they want you to come up with it. I just thought this was a good problem to do because it looks like you got chain rule in there somewhere, and it looks like you also got product rule.
Product rule.
That's why I selected it. That's the only reason.
The first one is product rule, right?
Right. The first one is product rule.
Uh-huh.
First times you're the second plus second times you're the first.
First. So T cosine T
T times cosine of t
plus sine T,
sine t times, what's the derivative of t?
1.
Okay, I'll leave it like that. Product rule, right?
Uh-huh.
That's why I selected this problem, just to update some previous calculus, like, oh, I need product rule because a variable in front of the sine of t. What's that derivative?
2T.
No, that's 2b. This one, look, product rule, but you also got a chain
Chain
rule.
rule, yeah.
Let me see the cosine of 2t.
Yeah.
Let's try this. All right, first,
T.
what's the derivative of the second?
So it should be negative sine
Negative sine of
2T
2t
times 2.
times the chain to 2. Everyone agree? Is everyone okay with that? Awesome. I mean, it's just somebody got, oh yeah, chain rule. So the derivative of the second was a negative sine of 2t times a 2. If you get confused between sines and cosines when it comes to derivatives and integrals, then this is just a mnemonic device. SCS, I put negatives on the third and fourth. Going that way is derivatives and going up is integrals. So what's the derivative of a positive c? The integral of a positive c is a positive sign. What's the derivative of a positive c? The derivative of a positive c is a negative sign. So if you like this, great, but it seems like no one has any trouble with that here. But sometimes I'll just see these on exams, just a way to just go, oh yeah, I don't want to mix this up.
Professor.
So I'm going to finish up product rule. The first times you're the second,
Plus
plus the second, what's the derivative of the t?
1. So yeah.
The tangent vector, that's the velocity vector. That's r prime of t. Cool. So on that note, if this is the tangent vector, yesterday we talked about lines, right? Parametric equations of a line. So, I'm going to give you a vector curve, and I'm going to ask you to find the parametric equations of the line that's tangent to that curve. So let me give you an example. I'll tell you which problem this is. I'd like to do two of these if you don't mind. I'm going to do 23 and 24. It's page 852. I'm going to do 23 and 24. The directions say this. Find the parametric equations of the tangent line to the curve at the given point. Alright, here's the first one. R of t.
Professor,
Yes.
can you give the equation for the parametric, for the line? How do you do the line? Do you remember?
Yeah, I'm gonna put it right over here. So for a line, it can be written like this, where you just put the x naught, and the y naught, and the z naught as a vector, plus the parameter t times some ABC, where this is the parallel vector. Okay? That's one way to look at it. But if they say the parametric equations, I'm going to think of this as what? All this combined, this would be xo, x naught plus an at, y naught plus a bt, and z naught plus a ct. But if they're asking for are the parametric equations, let's look at it. X is going to equal this, y is going to equal this, and z is going to equal this. The key is, what's this ABC? That ABC is a what? What kind of vector?
Parallel.
So now I'm going to draw a picture. Sometimes just a little picture helps. You got a line, you got a point, but we're looking for a vector that runs parallel to it and has, we'll put the components ABC down. Well, we need a vector that's going to be parallel. That's going to be key in this problem. We need the parallel vector at that point off that curve. So hey, another way I can write this, if they say the parametric equations, this was in vector form, right? Then what are the parametric equations of a line? X equals, y equals, z equals, x naught, y naught, z naught, plus, 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 t, and what's in front of these t's? The a, b, and c. I want to get out of the way. This ABC is the parallel vector. This x naught, y naught, z naught is just the point on it that they're talking about. Cool. But the key is these numbers right here will be the parallel vector. All right. And number 23. Everyone, here's the vector curve. It's funny because when he wrote this, I'll write it in a vector curve formation. They just wrote the parametric equation. 1 plus 2 squared of t. T cubed minus t. And t cubed plus t. And what's the point? The point is 302. So here's the point they're talking about, 302. We'll do that. Okay. Find the parametric equations of the tangent line of the curve. I'm still lost on what to do. I know these are the parametric equations of lines, so I'm going to draw a picture to help me understand this. This is a vector curve, right?
Mm-hmm.
Okay. Woo, and here's the curve, true? Here's some point. The point is what? 302. What are we looking for?
Parallel.
Yeah, when lost, we'll draw a picture. I'll draw a line. I need a line that goes like this. Right? I need the parametric equations of a line tangent to the curve at that point. Okay. Here's my answer. What's the point? Plus, plus. T. Here's my only challenge. Right here. What are these numbers? What is the vector that I need? What kind of vector do I need? I need a parallel vector to my line.
Mm-hmm.
Do you all agree from yesterday? I need a line, I need a vector that runs parallel to my line. A vector to run parallel to this line would look something like what? Like that? And I heard someone say it. What kind of vector is that? The tangent vector. So when they gave us r of t, all we have to do is, to get these numbers, is first find, I'll draw an arrow, we gotta find r prime of t. That's step one. That's gonna be easy, derivatives. But step 2 is we gotta know what t-value to plug in. That's the mystery. They did not tell you the t-value. That's not a t, that's what? X. That's not a t, that's y, that's z. The parameter is t. But let's start with this. When I need r prime of t. This is the tangent vector, right? The parallel vector is the tangent vector. We can see that. And then we'll plug it at some t value. Find the tangent vector at t equal to, I don't know yet. Well, can we just find the tangent vector first? Let's do the first one.
So
2, 1/2 times 2 is 1. 1 over root t. Let's do the second one. 3t squared minus 1. And the last one, 3t squared plus a 1.
well,
And then when I've seen this happen, I didn't want you to make this mistake on tests. This has happened. People write all this, and then they jam it all in front of these t's, and then they like distribute the t. There's one, I know, there's one more step. That's a point. We're going to evaluate these at a t value. The mystery is they didn't tell you the t value. So does anybody have a suggestion when we get lost like this? This is a theme in Calc 3. How do I know the daggone missing t value when x is 3 and y is 0 and z is 2? What's the t value there? Do you know?
Just said 3 equal to 1 plus 2.
That's the secret. So when this happens to you in our course, she goes, just simply go to the original point, just set it equal to the original x component, and solve for t. If it bugs you, maybe try these two. Pick the easiest of the three to figure out the t value. Right? What does 2 have to equal? T cubed plus t. Oh, that's too hard for me to solve. I'll try this one. 1 plus 2 squared of t has to equal what?
3.
So I'm going to just go off to the side. 1 plus 2 squared of t has to equal 3. By the way, you'll notice it'll be a very simple t value. It'll be a nice neat integer, probably like a 0 or 1 or a 2. I subtract the 1 on both sides. 2 squared of t equals 2. Do you know the t value? The mystery t value, t is equal to what? 1! That's what we're doing. So we're going to put here one r prime of 1. That's what we're putting in here. We're going to put the vector r prime of 1 right there. Not just r prime of t. We're going to put r prime of 1 as our tangent vector at t equal to 1. Don't let this bug you. It's either t equal to 1 or t equal to 0 or t equal to 2 when you got to do this. And the biggest mistake, people just put this in front of there. No. What's r prime of 1? They're nice numbers. This is what?
1, 2, 4.
See? There you go. Here's the answer. 1, 2, 4. Parametric equations of that line. That's the parametric equation of that line. You described it. Now you can find millions of points off that if you wanted to. This is the one I wanted to do 2 of, okay? So, can you try this? You ready? Why? Because this, I don't know, there's something about this that bugs students. Now, here's number 24. They've got x equals e to the t. The y equals, by the way, you both wrote them in parametric form. I'm writing as a vector. T e to the t. And the last one is t e to the t squared. Okay. Wipe this out. Can you come up with the parametric equations of the line?
What is the point?
And the point for this problem, 1, 0, 0. And you find the parametric equation of the line at the point 1, 0, 0. One, 0, 0, plus, plus, plus. T. And what do I need here? Parallel vector. R prime of what? What's the missing t value here? Right now? E to the t must equal 1.
One.
And what t value is e to a t equal to
0.
1? So does everyone agree this is going on at t equal to 0? This funny problem with a funny vector curve, and here's the point 1, 0, 0. We're saying the t value is 0. You all agree? All right, now go find that line L. T equals 0, because e to a 0 gives me a 1. Nice. Go find r prime of 0. All right, what's r prime? Of t. You gotta do that first.
E to the power t.
Derivative e t is e to t. What's your t to t in e product rule?
So t e t plus 1.
First time derivative of the second, plus the second time derivative of the first.
So
T times e to the t,
plus e to
plus
the
e to the t times a 1.
1. Yep.
And, okay, be careful on this last one.
It is product and what do you call?
First
Result.
times the derivative of, what's the derivative of e to the t squared? You need chain rule.
Yeah. 2.
2t e to the t squared. I got enough room. Plus e to the t squared. I'll write this again so it's not all crushed in the corner. And e to the t squared, e to the t squared times a 1. Let me rewrite all this. R prime of t equals e to the t, t e to the t plus e to the t by product rule. Then it was t times 2t e to the t squared plus e to the t squared times a 1. But everyone, would you plug what value of t into all that?
0.
Again, this has happened. Students take all this and they jam it all in there. No. We're evaluating this at the point, right? At t equal to 0. What's r prime of 0? E to 0 is 1. 0 plus 1 is 1. And what's 0 plus e to the 0? I got 1, 1, 1. You get the same? There it is. There it is. Parametric equation law? Cool. Hey, the next thing we're going to talk about is speed. What is speed? I know people know from calculus. I mean from physics.
Same as velocity but scalar.
Speed is the magnitude of the velocity vector. Alright? Speed is the magnitude of the velocity vector. Oh. So speed is not a vector. Speed is a
Scalar.
scalar. Right? I was traveling 55 miles per hour speed. Right? That's a scalar number, 55. So speed is the magnitude of the velocity vector. So try this. This is the position of some particle, and it equals e to the 6t comma e to the t minus 1. Can you find the speed at the point 1, 0?
Sure.
Find the speed at the point 1, 0. Okay? Speed is what? Magnitude velocity vector. So now I'm just going to find step 1. I need v of t. What's v of t? R prime of t. Which is? What's that derivative? 6e to the 6t. Good job at chain rule. Good job at chain rule. 6e to the 6t. What's your v t minus 1? You know, am I done? Wait, you gotta find the speed at that point. You gotta find the speed at that point.
So 6 into 6.
So here it is again, oh, and the mystery. That's not t, that's not t, this is x, this is y. What the heck is the t value again? This will be a common theme. Set this equal to the original what? Position? E to a 6t equals 1. What's the t value?
0.
E to the 0 is 1. So does everyone agree?
Mm-hmm.
I'll write it really big. I need to plug in t equals 0. Do you see what I mean? That's not given to you in the problem. That's where you can get a little bit lost in Calc 2. Don't let it happen. You'll find Calc 2 nice, just smooth ride. Just be careful when there's, I got this parameter, they don't give it to me, they give me x and y to set it to the original. So we're going to get r prime of 0 then, huh? What's r prime of 0? I mean, that'd be the tangent vector. Does everyone agree?
Yeah.
This would be the tangent vector at t equals 0. 6 times e to 0 is 6. E to a 0 is what?
1.
One more thing. What's the speed at that point? Speed is
6 square plus 1 square square root.
the magnitude of r prime of 0. Or you can write speed is the magnitude of v of 0, right? If you want to use v as velocity vector. R prime. Square root of
6 square plus 1 square.
how fast? Just didn't have units, so we'll just put square root of 36.
37.
Oh yeah, 37. Cool. Can we do another one of these? This only had what, x and y components? Let's do one with an x, y, z component. It goes fast. Again, be careful when they don't give you the what? This t value. Sometimes they do though. Sometimes they just, hey, find a speed at t equal to 5. You plug in a 5. Sometimes they give the point, and we gotta compare that. So when here's r of t this time, and they got e to the 6t. It's got 3 components. Cosine of t, sine of 2t. Can you find the speed when t equals 0? Ah, this time they told you the t value. But can you find the speed of this particle when t equals 0? Well, again, we'll find r prime of t, and then we'll get r prime of 0. Then we'll take the magnitude of r prime of 0. Well, the reason I want to do another one, everyone, it just gives us extra practice with things like product rule, chain rule. What's the e to 6t?
1/6. Sorry, 6.
Well, let's do cosine of t.
Negative sin.
Oh, let me write it down again.
Negative.
S, C, S, C, S. Why do you know this, but just if it helps. Am I going that way or this way? I'm doing derivative. So what's the derivative of cosine? Negative sine of t. And what's this derivative?
2.
Go, cosine 2t times the chain 2. Now what do we got to plug in here? 6 times e to 0? What's sine of 0? 0. Cosine of 0? 1. So what's that magnitude? What's the speed?
Square root of 40.
Shut up. 2 squared is what? 4, and I get square root of 40. Or if you want to simplify that radical, what's that? 2 square root of 10. Cool. Hey, try this. If you can do derivatives, can we do integrals? Going about integrals, just remember, we're going to have to use a plus constant, true? We're almost done with section 13.2. We did the derivatives, but let's just practice a couple of these integrals. Okay. This is going to be very helpful for next week. Coming on Monday, when we see these like space curves, and we see like a ball being thrown in the air. We can travel this stuff, we can actually find the actual formula that represents that position at any moment of time. All right, v of t equals sine of t 4e to the 2t and 5t squared. This is velocity, or the tangent vector. The question is, can you find the position vector? And in fact, they gave us 1 point. They said the initial position, I'm going to go off to the side, I'll get this out of the way. The initial position for this problem, r of 0 equaled 1, 1, 1. This was given. This is the velocity vector. And they want you to find the position vector. This is the velocity vector. Can you find the position vector? What's going on here?
So integrate.
Position, velocity, acceleration. I'm going from velocity position. We have to do what?
Integrate.
Integrate. And then we'll use this to help us find those constants. Does that make sense?
Mm-hmm.
So don't forget to put your little plus constants in each one of these components. Well, let's try it. All right, R of t. Just ready? What's the integral sign?
Negative cosine t
Plus the c. What's the integral of 4e2t? Good job, everyone. What he did was, he divided that 2, because it wasn't a derivative, it was an integral, which became a 2e to 2t. He actually did a u sub, if you think about it. Plus constant, and what's that integral?
5 over 3
5t cubed over 3 plus a.
c.
Yeah, now these are all different constants, so if you want to distinguish between each constant, you can call that constant 1, constant 2, and constant 3, because they all are just representing different constants. Right? But how do I find these constants?
It's equal to 0.
Yeah, it's all about this. There it is. Hey, I didn't want to rush you on this. Was everyone okay with that one? That was not, I mean, that's the old, oh, I got to do the integral of 4e to 2t. 4e to the 2t, and that did involve a u sub, and we ended up just dividing a 2 from that rather than multiplying it from it. All right, so I'm going to write this. Negative cosine of 0 plus a c must be equal to the number 1. I'll just put a big wall just to separate this from this. Did everyone see what I did? This is to help me find the first constant. Negative cosine of a, that's a t value of 0, plus a constant must be equivalent to that number 1. Let me do it here. 2 times e to the 0 plus a constant must be equal to the number 1. And how about over here? 5/3 of 0 cubed plus a constant must be equal to the number 1 as well. Because this gave us all these components. What's this c value? See, cosine of 0 is 1. What's this c? Whoops.
2.
C is 2. Okay, got it?
So that's e to the
2 plus c equals 1. Negative 1. And 0 plus c equals 1. C is just a what? 1. So I'm going to write the final answer right here. Here it is. R of t equals negative cosine t plus a 2, comma, 2e to the 2t plus a negative 1, and the last component is 5t cubed over 3 plus a 1. There's my answer. There's the answer, there's the vector curve. R of t is negative cosine t plus 2. 2e to the 2t plus negative 1, which I could change to just what? Minus 1. I'll do that. And then 5t cubed over 3 plus 1. Nice? Now I'm going to extend this. Can you find the position of this particle at t equal to 1? Can you find the position of this particle at t equal to 1? What would you do?
1.
So the question is, that was the position vector. found it. But they said, now find the position vector of the position of this particle at a different t value than 0. And they said, find the position at 1. Now we just have to plug in a 1.
Well,
I just want to see, the answer may look funny because when the cosine of 1 radian is not neat, right, it's irrational, so I'm going to leave it as negative cosine of 1 plus 2, 2e to the 2 minus 1, and 5/3 plus 1. At least I could do that. What's 5/3 plus 3/3? 8/3? You know, great question. When they asked this, when they said find the, yeah, actually the question, I'll be clear, they said find just R of 1. So they just wanted to find this. The other one's that. We did integrals, we did speed, we did that. You know how to do a tangent vector, right? You know how to find that missing t, true? Cool. So this is the last thing we're going to do. This is the last problem. We're going to find the angle of intersection. So as I write this on the board, can you just think back to anything we've done that dealt with an angle?
yeah, the dot product, right?
Dot product.
Something we've had before, right? We're going to find the angle of intersection.
Dot product was cross with cos, right? Cosine.
That's right. Let me grab this problem one.
The cross product was sine. Right?
Don't worry, if I don't find a good problem out of here, I'll just make one up. 13/1 got it? Find the angle of intersection. 13/2. Here you go. This is on page 852, 13.2. This is number 33. Find the angle of intersection of these two vector curves. R sub 1 is t squared t cubed. R sub 2 is sine of t, sine of 2t, and t. Sine of t, sine of 2t, and t. All right. So here's the two space curves. These are the two vector curves. And they want you to find the angle of intersection. So find the measure. Find the measure of the angle of intersection. Now, I'm hearing this word angle, right? We go back to this previous chapter, and you said there is a formula that involves angle. It was A dot B equals magnitude of A, magnitude of B times a cosine of theta, right?
Yeah.
We recall that. So what's theta equal to in this formula? Cosine A dot B over magnitude of A, magnitude of B. Okay. So we got it. We just need to know what vectors are going to be A and B from these vector curves. I mean, these are just two vector curves that are what? Come like this, and we come up where they intersect, and we want to find the angle intersection. What kind of vectors should we use off these curves to find that angle? Because with the angle, we think what? Straight lines and stuff? So we need straight vectors. What kind of vectors? Tangent vectors. So for A and B, let's find the tangent vector to this curve, tangent vector to this curve, and we'll find the angle of intersection. And I have to give you the point, don't I? In this problem, they said at the origin. So find the measure of the angle of intersection at the origin. What's the origin?
0, 0, 0.
So that's going to be the point 0, 0, 0. So that way, once we get these, R prime t, which is what? 1, 2t, and 3t squared. What's this one? What's R prime But this cosine t, be careful. 2 cos 2t, chain rule, good. And up.
1.
What's the t value here? Here we go again. That's an x, that's a y, that's a z. What's the t value for that? Yeah, no tricks this time. T is equal to 0 here, right?
Oh, yeah.
T equals sine of 0, 0. The missing t, that's what I'm talking about. They didn't give us this t value. They give us the x, y, z. This is going to be at, I'll put it in yellow, at t equal to 0. Because that's what gives us these values for x, y, and z. So now let's find r prime of 0. 1, that would be 0, that would be what? 0. What's r prime over here at 0? Here's our two vectors. What's cosine of 0? 2 times 1 is 2, and a 1. Just A dot B them, get the magnitude, and we're going to have the angle. Alright. Hey, what's the dot product of these two vectors? 1 times 1 plus 0 times 2 plus 0 times 1 is 1. What's the magnitude of that vector? 1. What's the magnitude of this vector?
1 square plus 1.
Square root of 1
5.
squared plus 2
6.
squared plus 1 squared.
6.
Now, does anybody have a calculator handy? Just so we can see what this is. Thank you so much. And you can put it in degrees. He's going to put it in degrees. Thank you for doing that. What's the inverse cosine of 1 over rad 6? Everyone's super job. Super duper job. That's 13.1, 13.2.